Thank you very much for LatinX for inviting us to this workshop. Thank you, ICML, as well. What we are presenting is work that we did in AI for the preservation of cultural heritage, in particular applied to art restoration. Thank you to my co-authors as well, and everyone who has been involved in this project. So what we have here, it's imagine you have this image on the left, and then you want to reconstruct it, and basically because it's damaged. And one way of reconstructing is actually the image that you see on the right. This is the actual living reconstruction of this image. This is the Ecce Homo in Spain. It's a fresco on a church, and well, this can be a possible reconstruction that you can make. There is another reconstruction that we can make, that it's this image now on the right. So our question is, how do we scientifically assess one reconstruction from the other? Why do we say that this is better than the previous one? And most importantly, how do we produce better reconstructed images or artwork? This is another artwork that we have worked on. This is M.C. Escher's print gallery from 1956. And since Escher's death in 1972, people have been wondering how to complete the missing center. As you can see here in the center, the image is very rotated, very twisted, and also the objects are very small. So this poses big questions for reconstructing the missing piece of this artwork. So basically, the idea that we propose is you have an original artwork, you take a picture, and then we will work on the picture. The two questions that we answer is, how do we generate missing content, the content? Like, how do we reconstruct the objects that are missing, or the colorization, or the blurriness? And we work first on the image of the painting. And then, how do we evaluate the generated content? Because as you know, every generative model will generate you options for you to choose from. So how do we choose, for example, the first one over the other options that the generative model is giving us? So basically, this is the questions that we try to answer with this work. First of all, we will tackle the content part. So how do we come with a model that can generate good content in resonance with the artist, the period, and the painting itself? So what we propose, it's diffusion-based models, because we will see they work very well, and they have expression and diversity. And this is exactly what we want to reconstruct art. There are particularly two text-guided diffusion models. First, we have Glide, that it's an open box. It's a white box model. That means you can actually see the code and manipulate the code internally. That means you can do back propagation inside the code. And then DALI, DALI 2, which has been popular. Both are combined text and diffusion models, so it's text guided diffusion models. But DALI is a black box, so that means you enter a prompt, and then you get a reconstruct image without having any access to the internal code. So diffusion models, very quickly, they have the same premises as GANs. You start with noise, and then you want to reconstruct an image, but they don't have the discriminator architecture, this GAN idea of generator and discriminator. This is basically purely learning to denoise an image. And then once we have learned to denoise, we can use the gradients of the process to shift into a guided diffusion. So the guiding of the diffusion, if you have wide access to the model, you can guide the diffusion with the text prompt, as the clip model that has been shown in the previous presentation, Or you can use any gradient and do backprop on the diffusion, for example, to guide the diffusion towards a painter that you want or a sentiment that the painting has. So that's the beauty of diffusion models. If you have a white box access, you can use the gradients to guide the content generation. What if we don't have white box access to the model? So if we don't have white access to the model, any generative model will generate, as we say, several examples of possible in-painting options. And we can, even with guiding the diffusion, how do we select the best option? So what we propose is to generate an AI art critic, as if you have a connoisseur in Picasso or a connoisseur in Van Gogh, that it will tell you, from my years of experience in the matter, this in painting or this restoration will be the correct one. But we will generate that artificially with AI. So basically, we have an image that we want to in-paint. This is a part of print gallery that you see here on the top left. This is part of print gallery, and we want to restore or fill in the missing portion in the white part. So the input to the model, it's a image that we want to reconstruct, a mask, and a text prompt. The diffusion model will take the text prompt, and it can do clip-guided diffusion, and it will generate you virtually infinite possible solutions for your in-painting problem. Then we train a discriminator that will give us the probability of that this in-painted image is a true Escher. This discriminator is our art critic. It will help us select true from fake art. And it will assign to every image the probability that it was originally painted by Escher. So it's basically, in a sense, fooling the discriminator to believe that this in-painted image is real. The discriminator architecture that we used is simply a DC GAN. You can train it with a particularly artist data set. For example, if you want to restore a Van Gogh, you take all the artwork of Van Gogh, and then you pass that as simple supervised learning of good examples. Or you can also use WikiArt, which already has labeled data for painters, and you have sentiment analysis, and you have schools as well of paintings, like, for example, modernism. So you can pass to your discriminator, like, this is what a painting in modernism will look like. So that will allow you to enhance the sample, or actually to have more samples. Then the last layer is a softmax. So because we want the probability when we input an image that has been in-painted or restored, the probability that it's a true one. So basically, we output a probability distribution. Then, how do we evaluate what we have produced? We took human evaluators, and the first thing we asked them is, we have, in our study, we have 10 randomly selected people who were volunteers, and we asked them, if we want to in-paint or we want to restore a painting by Escher, first of all, let us know how much of an Escher connoisseur are you? Because if you have never heard of Escher, your opinion would probably be weighted to 0, unfortunately, while if you are an Escher expert, your opinion will be weighted to the highest degree. So we use the self-assigned points to then weigh the opinion of this human evaluator. And then we said, we will show you many in-painted, we will show you many images, give us a probability of these images of being an Escher. So here we have one of the examples that we use, and this is the model evaluation. All these 5 images that you see are in-painted options that, in this case, was Glide, in-painted options that Glide gave us. So basically, we input to the model this image with the mask, and Glide gave us all these options. And then it's for us and for our model to select which would be the most likely that belongs to an Escher. And then you see on top the probability of being an Escher that our model assigned with the probability that a human assigned. And we see that these two, the ones on the right, are the ones that match very well with Escher style and with print gallery itself, with the painting and the time period of the painting itself. The others have a lot of artifacts. These artifacts come as a byproduct of this expressivity that diffusion models have. So some people did assign some probability, for example, of this one of being an Escher, because it has the symmetries and all that. But our model said, well, these columns do not belong to the time period and actually the surroundings of this work. So other models that, other paintings that we worked on are, well, Escher. This is a painting that has been burned, so we reconstructed. This is the Ecce Homo, and this is a Cézanne that Cézanne left unfinished. So basically, we are proposing a model that will aid the reconstruction of artwork. Then you can come to our poster today, or you can follow our work on Instagram. Thank you so much.
Thank you, Lucia.